Hello and welcome back to Joe Baylor Revision. Today we're going to be looking at Chemistry Topic 8, which is all about chemical analysis. So let's begin. So let's start by looking at chromatography. But first, let's look at the things that go into chromatography. We'll put in either pure substances or formulations. Usually formulations as we want to find out what they're made up of. Pure substances are made up of a single element or compound. Remember, a compound is multiple elements that are chemically combined. So the thing about pure substances is they have one specific melting and boiling point. So if we want to test for a pure substance, we can figure out its melting and boiling point and see whether it has multiple of either. And if it has multiple of either, then the substance is not pure and it must be either a mixture or a formulation. So another way to determine pure substances is whether they have only one dye spot in chromatography, as the amount of dye spots in chromatography points out the amount of elements or compounds that make up the mixture. So next let's look at formulations. So a formulation is a mixture designed as a useful product. So an important thing about formulations is that components are mixed in exact proportions, because we want to get these exact properties and exact attributes for what we want to make to do work and to do a specific job. So some examples of formulations are fuels, paints, medicines, and cleaning agents. And a lot of these are used very specifically, so we want them to be a very certain thing. So next, let's look at actual chromatography itself. So it's a process that's used to separate mixtures and identify the substances which make up them. And in chromatography, we look at it as having two phases. These are things that are used in chromatography. So we have the stationary phase and the mobile phase. So the stationary phase is the non-moving solid or liquid. So in the required practical we do, this is the filter paper, as the actual thing itself doesn't move. However, there's also the mobile phase, which is the moving liquid or gas, which how we do it in the required practical is the water, as it submerges the filter paper. So next, let's look at the RF and the actual equation of chromatography. So RF is basically a ratio of the amount moved by the dye over the amount moved by the water. So if we look at this diagram here, you can see that the blue line is the bit that's how far the dye's gone from the origin. And the black line is how far the water has gone from the origin up to the top line, because the dye starts at the origin and so does the water. So it really shows the difference between it. And the thing is, because we're doing the distance of the dye divided by the distance moved by the solvent, that means that it's always going to be between 0 and 1, because the dye always goes less than the top line. It's always going to be smaller. And the important thing about the RF really is that certain substances have certain RF values, specific ones. Meaning, in an exam, they could give you a table full of RF values. They could ask you to calculate it for a certain thing and then say, okay, which actual substance is it? Compare it with this table. It might not even say compare it with the table, but it'll give you the table. And you have to figure out from the RF which substance it is. So you could be like, oh yeah, 0.54, that must be this compound or this element, that sort of thing. So that's a clever way they could do it. Also, you definitely got to remember the equation for this. So it's RF equals distance moved by substance over distance moved by solvent. So next, let's look at identifying common gases. So there are 4 common gases we test for. That's hydrogen, oxygen, chlorine, and carbon dioxide. So we test for hydrogen by placing a burning splint at the open end of the test tube. And after doing this, the gas should burn rapidly and a squeaky pop noise should be made. So this squeaky pop sound is the actual scientific term for it, and that's what noise it makes after the thing's been burnt, when the thing's been burnt. So next, let's look at oxygen. So to test for oxygen, we have to place a glowing splint in the test tube. And if oxygen is present, the splint itself will relight with a full flame, as it was before it got turned into glowing, of course. This links to, of course, the fire triangle, because you've got oxygen, fuel, and heat in it. So next, let's look at chlorine. So we can test for chlorine by getting damp litmus paper and putting it into the chlorine gas. And the thing is, if it's real chlorine gas, then the litmus paper is bleached and turns white. So that determines its presence. So next, let's look at carbon dioxide. So if carbon dioxide is present, if we put it into lime water, the lime water will turn cloudy and get a load of bubbles. So that's how we know it. So next, let's look at flame tests. So flame tests are used to find metal ions. And sometimes a mixture of ions causes some to be masked. So if you've got multiple metal ions in something, it can sometimes confuse it. So if you've put something stronger there before and then you're testing for something else, sometimes it masks the second thing. And flame tests are done with a Bunsen burner, of course. That's a tall metal thing with the flame on it. So if there is a lithium compound being tested, it would make a red flame. If there was a sodium compound being tested, it would make a yellow flame. If there was a potassium compound being tested, it would make a lilac flame. If there's a calcium compound being tested, it will make an orange-red flame, and copper makes a green flame. So you just got to remember all these. It's a way of testing what metal's going to be there, is what colour the flame turns. So it could turn red, it could turn yellow, it could turn lilac, it could turn orange-red, or it could turn green. You just got to know which metals to join this up with. So next, another thing related to flame is flame emission spectroscopy. So this analyzes the metal ions, and basically the light from a flame is put through a spectroscope. And because certain readings off the spectroscope show certain metals, because it really shows, spectroscope shows what type of light is being absorbed by the metal and that sort of thing, and how much is actually staying in the flame. And because all different metals absorb all different types of light, we can determine it from that. So this is another thing where it may give you a table, it may give you an example, it may say this type of metal does this under the flame, it absorbs these things, so it'll show you it as a diagram. So that can be useful. So yeah, it's because certain things absorb different parts, and remember the light is on the visible spectrum. So next, let's look at sodium hydroxide tests. So sodium hydroxide solution is used to test a lot of things. And when it's used with all these things, it creates a white precipitate. So that's when it's used with magnesium, calcium, or aluminium. And there's an important thing about aluminium. When the sodium hydroxide is put in excess, creating an excess solution, the actual white precipitate will dissolve completely, meaning we can use that to rule it as different from the other three. So if we want to determine which one of the three it is, add it in excess instead, and if it dissolves, it's aluminium. And another thing, if that was a 2-mark thing and we had to find whether it was magnesium, we could then burn it in a flame, and we could see if it makes an orange-red flame. If the flame is an orange-red, it can't be calcium, so it must be magnesium. That's the thing, these things, all the different tests, they sometimes make them all linked together in exam questions. It's very interesting because it's like going to be multiple marks because you need to draw from multiple places of knowledge. So also, sodium hydroxide, some things, when they were mixed with it, create coloured precipitates. And this includes copper 2, which creates a light blue precipitate, iron 3, which creates a reddish-brown precipitate, and iron 2, which creates a green precipitate. However, iron 2 only creates a green precipitate when it's in an excess solution, which means only when it has extra sodium hydroxide in there. So next, let's look at the last 3 things: carbonates, sulfates, and halides. So let's start with carbonates. So carbonates, we add acid to them. And if they produce CO2, they're carbonates. And the thing is, to find out whether it's CO2 or not, we see if it turns lime water cloudy, of course, from the test we've seen earlier. So you just got to use another test in this to find out if it's carbonate, which of course carbon's in the name, so it makes sense. It releases CO2. Sulfates, you've got to add barium chloride and hydrochloric acid to it. And if it creates a white precipitate, we got us a sulfate. So next, let's look at halides. So a halide is something that we need to combine with silver nitrate and nitric acid. and if the mixture turns white, then it's a chloride. If it turns cream, it's a bromide, and if it turns yellow, it's an iodide. So these are all things at the end of compounds, so it'd be something chloride, something bromide, or something iodide. So of course these are all tests for compounds. So yeah, that was chemical analysis, chemistry 8. So I hope you enjoyed it, paper 2 of course. Thank you for watching. I should have more chemistry up soon, and we uploaded today after yesterday, which was very good. We probably won't be around tomorrow, but thank you and goodbye. Also, thank you for 100 subs. Goodbye.